In this particular video, let's see what encoding is and let's try to achieve it with help of Sklearn. There are three types of encoding: label encoding, ordinal encoding, one-hot encoding. When do we use encoding? Whenever you have in your data frame, you have a column which is of string data type, a categorical column with string data type, and you want to convert that into your numeric data type, you try to use encoding methods. First method which we are going to see is label encoding. When do we use it? Mostly label encoding is used for your dependent variable, which is your y. Okay. In machine learning, you have x and y. X are your independent variables, y is your dependent variable. We use label encoding for dependent variable. Okay. Label encoding expects an input of 1D array. Ordinal encoding, one-hot encoding are used for your independent variables and they expect 2D array. Let's start. Label encoding is particularly used when you try to encode your dependent variables. This is what your label encoding looks like. Let's say you have a data frame with following columns: name, sex, team, NOC, games, season, city, sports, events, and medals. In order to convert your dependent variable, which is medal, which is of string format, to a numeric format, what you will be doing is you will be using label encoding. Okay, you will be using label encoding. Now, when we speak about categorical columns, there are two types of categorical columns. First is a categorical column which has an order, which is your ordinal. Okay, and second is a categorical column which is not having a specific order. That will be your nominal. Okay, to give you an example of ordinal categorical column, it will be your medals column, in which bronze, silver, and gold are basically having a order. Gold is greatest, then comes silver, and then bronze. To give you an example of nominal column, there is a column called as city or sports, which is of string data type and is a categorical column, but there is no specific order that football is greater than ice hockey or ice hockey is greater than athletics. Okay, so whenever there is no order, you use one-hot encoding. Whenever there is no order, you will be using one-hot encoding. Whenever there is order involved, you will be using ordinal encoding. Okay, this is for your independent variables. For your dependent variables, you will be using label encoding only, irrespective of what your dependent categorical variable is. Okay. About ordinal encoding, there are few keynotes which are difference between ordinal encoding and label encoding. Your ordinal encoding is for independent feature, your label encoding is for your dependent feature. Ordinal encoding, inside ordinal encoding, you can define your order. That gold should be first, then should be silver, then should be bronze. That is not in the case of your label encoding or in case of one-hot encoding. Ordinal encoding expects 2D array as an input. Label encoding expects 1D array as an input. That's why label encoding is used for dependent variable and ordinal encoding is used for your independent variable. For your one-hot encoding, you have a column called as sports, which has football, ice hockey, athletics. Clearly, there is no ranking between each specific category. So what you try to do is you try to create a new column. Okay, you will try to create a new column in which you will expand your data frame horizontally, and where each extra column will be added for your each sports. Okay, so let's say this thing represents, this column represents your football. So whenever there is a football in a row, the value of that column will be 1. If there is no football, the value will be 0. Okay. Similarly, let's say this represents your ice hockey. If your first row is not having ice hockey, the value of this cell will be 0. If it represents ice hockey, which is in case of second, you will add 1. The value of that cell will be 1. This is how your one-hot encoding works. It tries to increase your data frame horizontally by adding a column for each specific unique category. Okay. Moving on, let's see the implementation in Python. I have a data frame. I try to read the data frame stored in a variable called as df. This is what my head looks like. In this case, I have dropped all the nn values there are in data frame. This is what my head looks like. Next, what I'll be doing is I'll be seeing the tel. And here in X, I'm only including objects of string data type. Okay, so all my columns are of string data type, which is name, sex, team, NOC, games, season, city, sport, event, and medal. If you see age, height, weight, Here, these columns have been discarded. Only columns which are included as of string data type. Now we know where do we need to use encoding. Next step, let's try to do label encode. Label encoding will be done on your dependent variable. So you have bronze, silver, gold as your dependent variable for your del. And for your head, you have bronze, gold, gold. Let's see. In order to do your label encoding, what we are going to do is from your Sklearn, you will import pre-processing, and in pre-processing, you will be creating an instance of your label encoder using function called as .label encoder. Now what I'll be doing is I'll be applying .fit transform on your column df of medal. Now df.head looks like 00111. Okay, originally it was bronze, gold. Now it is 00111. If you want to decode the value of this numeric value, you will simply do le.inverse transform 012. You will get 0 is for bronze, 1 is for gold, 2 is for silver. Okay, because it is dependent variable, the order won't matter, right? But let's say this was your independent variable. The middle column was your independent variable. The order would have been mattered, and gold should be your 0, bronze should be your 1, silver should be your 2, or else gold should be your 2, bronze should be your 1, and silver should be your 0. Sorry, gold should be your 2, silver should be your 1, and bronze should be your 0. Okay, so the order of gold, silver, and bronze will matter if it is an independent variable. In that case, we will use ordinal encoding, although it is used for independent variable. Just to give you an example, I'm trying to use it for your medal column. Again, what you are trying to do is I'm trying to import from sklearn.preprocessing ordinal encoder. Okay, in ordinal encoder, what I can do is while defining an instance of ordinal encoder, I can specifically mention my order. Okay, so it will be bronze, silver, and gold. Now, if I try to use fit transform on your medal column, it will give me encoding in my specific custom order which I've mentioned. Okay. As I said, ordinal encoding and one-hot encoding are expecting a 2D input array. That's why you need to add an extra pair of square brackets. Moving on, if we try to see the inverse transform of this, you will be having 0 as your bronze, 1 as your silver, 2 as your gold. It is my custom order which I defined. Let's go to nominal data, city. I'm using column city. I have a city column here. We can't order city. We can't specifically mention Sochi is above London or whatsoever. So what we try to do is, for using one-hot encoding, first step is to label encode the column, extract your features, and then convert it to your data frame. Let's see how it works. Again, what you are going to do is you will be using pre-processing.one-hot encoder, and drop is equal to first, which means basically you are always dropping your first column. Let's try to discuss this in some other video. Why do we need to do this? But it is an important step for your dimensionality reduction. Okay, we have created an instance. As I said, first step should be to label encode your column which you are going to one-hot encode. So I have label encode my city column. Now I'll be converting it into an array. Okay, so I'll be converting this thing into array. Okay, and these are my features. So I've extracted my features, and now I'll be creating a data frame of it. Okay, this will give me a matrix, and this matrix I'll try to use it with help of, I'll try to convert it into a data frame with help of pd.dataframe. Using pd.dataframe, what is the thing which I want to convert into a data frame? What is the matrix? It is encoded features, which is basically a one-hot encoded of city column into array, and then I give the name of columns. Okay, the name of columns will be get feature names of city. This will basically give you city 1, city 2, city 3, city 4, so on and so forth. Okay, you just need to do this. This is your data frame which has been created. Okay, if you see total unique values we have had were 42, and now we have only 41 columns. Why? Because we used drop is equal to first. Moving on, I have two data frames. One is this city 1 to city 41 data, and second is my original data frame. Okay, this one. So I'll try to merge both of them. Let's see how to do it. I'm trying to merge df and encoded df. I'll try to concatenate on axis 1, which is by columns. I'll try to concatenate, and this is what my data frame looks like. This is what my data frame looks like. Okay, this was all for the video. Thank you. Let's meet in another video. Bye.